Yeah. Okay, should we get started? Okay. To here. Okay. Okay, but most of the speakers will just be perfect. Okay, let's get started then. I'm happy to see there's so many people after yesterday's dinner, this early in the plenary hall. This morning's first session is about building platform partnerships for the future. The background here is, or maybe I should first introduce myself. I'm Ari Asmi. I'm the director of the European RDA Association. Background of this session is that we have this kind of vision of seamless interoperability between data, software, and high performance computing. And this has still remained quite elusive in most cases. And sometimes the issues are technical, sometimes the issues are more related to people and relationships. And we have tried to collect here 4 very different kind of experiences of trying to build this kind of interoperability between different kind of service providers, or in some cases between different countries, and trying to get them to work together. Without kind of further ado, because we have a quite tight schedule for this session, let's go to our first speaker, Professor Delian Chen, who is a professor in geoinformatics at the University of Gothenburg and former executive director of International Science Council, former chair of the Scientific Advisory Committee for Environmental Climate Data Sweden, and coordinating lead author of the latest IPCC report. So please, Professor Chen.
Thank you, Ari, and good to see so many colleagues here in this big hall. And has been some times ago I speak to such a large audience. Nowadays we're used to sitting just before the computer doing the lecturing. So my pleasure to be here. When I was invited, I thought it was really a very good idea to talk about partnership, talk about the collaboration, and also this integration between software, etc. And in my previous life as the executive director of International Science Council, we have been working a lot with data, actually. And I saw some colleagues from Core Data, for example, which is a ICSU committee, and also International Science Council has established a world data system in Japan when I was the director. So it's a lot of, why is this important to International Science Council is because actually data is something that can really bring all different disciplines together. And in science, we are not very good in collaboration, I have to say, if you look at the history. But here we have one example. I'm trying to give you a kind of big picture and also to show you actually this type of integration is not only elusive. It can be real, it can be successful. And you probably have heard 3 days ago, the IPCC released the latest synthesis report. IPCC as scientific assessment body has been hugely successful, I would say, in impacting policy. Well, you might not agree with me because, but anyway, the voice is there. And I'm also personally not impressed by what we have been doing. That's why I show you this depressive picture in my front page. But anyway, I'm going to talk about a little bit of climate science, because I think we can learn a lot from what has happened. So let me see how this works. Yes. And in this latest report, actually, we succeeded. I was coordinating leader also. So I pushed very hard at that we should reflect on the role of science and the history of science behind the IPCC work. So we succeeded in doing that. And I'm not going to, of course, go into details of as in many scientific disciplines, you have data actually. Usually it's something you start with. It's the same with climate. But I think what has been hugely important is that we have something called a WMO, a UN body, which collects data, coordinating data, and also do a lot of integrative work, I would say. WMO is one of the few UN bodies that has been really successful in doing that. And also we have IPCC, which is something new. Actually, IPCC, you can see that it came about in 1988. It's not so many years ago, because a professor, Swedish professor Bert Morning, who is also ICSO, actually, International Science Council, because they had a committee chaired by Professor Bert Morning, who came up with the idea to establish IPCC. And I showed two pictures here, three pictures here, and two of them here are climate scientists who got Nobel Prize in Physics 2021. So it's a huge success. But my point here is really that we started with data. And I just want to quickly talk to you about this transformation within climate science. I think a few very important things happened. One is that it has been transformed from basically an atmospheric science to something much bigger. We would call it today transdisciplinary, not only disciplinary, but also transdisciplinary, that we work with people outside, like academia. I think is equally important in this context. And also we have been taking a system approach. And also prediction is the key, because when we talk about climate change, you have to do prediction. And technology has played a huge role in how we connect data, how we process data, how we integrate with modeling, etc. So all this, I think, is important for successful partnership. And also we have to really work with societies, not least the political world and private sector, of course, for that matter. And the other things, probably, I know people here, many colleagues are quite technical. And but from climate, we have learned that we really have to become more cultural and social, because the challenges we are facing are not only technical, not only scientific, but also there is at least a social and a cultural context. And actually, if we are going to deal with solutions, not only just identification of problems, that is also absolutely necessary. That is, I think, is a big message I want to give. And another thing I want to mention is that when we look at the science for society, for sustainability, actually, we tried with the International Science Council some years ago. I led a process for the visioning, looking into the future. What is important? What are the grand challenges? As you can see here, that we came up actually just with 5 such grand challenges. And 2 of them, forecasting and observation, have to do with the data. Because as I said, in order to do prediction, you have to use complicated models. And complicated models like climate model is producing huge amount of data, as you know. And also we have a lot of observations. And so I think the community here has a challenge, but also an opportunity to really to help the society to transform and to work with sustainability. Because I mean, to deal with 5, actually we have done this in 3 years, involving like 3,000 scientists around the world, including 60 plus Nobel Prize winners. And we came up with only these 5 grand challenges. Just give you another example in terms of observation. In climate, we have WMO again. We have something called a G-course. We connect data. That is obviously natural, but also we talk about actually societal elements here. And we define something called 9 societal sectors, which means we really targeting use of information and also collaboration with these stakeholders, if you want. That is something I think is something has been transformative for climate science. And modeling, as I said before, it's complicated model. We produce tons of data. Within IPCC, we have something called CMAP, which is Global Coordinated Climate Modeling, a lot of data. And that data has been actually successfully shared and used, in my view. And we are doing this kind of modeling work even more with final resolution that creates even more data. So it's a huge challenge, but I think the community is doing pretty well. And of course, in that process, as I said, it's not only just climate. You have to really start from socio-economic development. You know, we're dealing with adaptation. You have different sectors. We also look at the mitigation, the policy, the political world, etc. So I think this is a typical transdisciplinary science. And it has become so natural, actually, nowadays within climate science. So take-home message 2, number 1 is that I think the data and the model data, of course, model-produced data also has played a huge role. And also, I think the common frameworks or system is really important to facilitate that integration and to make things happen and to make science useful. And IPCC has been fairly successful, as I try to claim. And I'm looking forward to more interactions with you. Thank you, Chair.
Thank you a lot for this presentation, and especially thank you for keeping the time extremely well. So we do have actually time for some questions from the audience or from online, if anybody wishes to have any. There is one in the back.
Thank you, Professor. My name is Shelley Stahl. I am Vice President of Open Science Leadership at the American Geophysical Union. It is very delightful to hear your talk this morning. Thank you so much. I'm wondering if you could think about how important, taking into consideration what you just presented to us, the importance of climate science to the world coming from the International Science Council. Can you provide some guidance to organizations like Research Data Alliance and the AGU on how we can help further that work?
Thank you, and it's a very good question. I think there are at least 2 ways to do that. Actually, to start with, I have to say that the contributions that the scientific research community is making actually coming from a lot from the people in this alliance. I see from data side, also from AGU, from climate science side. So that is one thing. Already your members has been really important. There are a number of international programs such as WCRP, which is a World Climate Research Program. Actually, all the leaders come from almost AGU, I would say. And then we have also another data-oriented organizations. So that is one thing. The members, which is really the people who are behind this. And then also, I think there is a lot of things that can be done still to enhance that collaboration, because you are the International Science Council, international community are organizing members quite often in their personal capacity. I'm a climate researcher. I have been involved also. And I'm an AGU member, by the way, also. And but that is not good enough, I think. And because AGU has such a, and also this alliance, I think has such a great potential to create your own group view and opinion. And because when we talk about the world science, you know, it's impossible. It's such a huge. When I was the ICTU head, and we have 140 countries and many organizations, and so it's impossible for us to really come up with a good view covering all different aspects. I can tell you one example. We were given one task by UN before the Rio +20 meeting. And because at that time, for 2012, the UN want to create this SDG, the Sustainable Development Goals. So we were tasked to come up with a list of possible candidates. I tried very hard. I remember I traveled to 50 countries. We organized many meetings, several thousand people, as I mentioned before. We tried to come up with this, but still we see we don't have the whole coverage. So I really hope that the organizations like this, Alliance, like AGU, can help us to facilitate this, when we do the scoping, IPCC is the same. And you can play directly a role into this process and to help international organizations to make scientific voice heard. So that would be my 2 suggestions. Thanks.
Okay. Any other questions from the audience? Please, in the front.
Thank you, Professor. It was like always wonderful to know about the IPCC report, and we hope that it will be a best use. My question would go back to the process. I'd like to ask you the very simple question: what was more difficult, to collect the data or to get people together? And yeah, what is your view on that? What was the biggest challenge?
Yeah. Very good question again. No, I think the biggest challenge is not collecting data, and although it is challenging enough, but it's compared to the interaction between science and the policy world is the biggest challenge. I'm still thinking personally. Also, I think the community is still struggling about what to do, how to do. Recently, for example, you have AGU. We had 2 colleagues in the AGU meeting who kind of acted as an activist because we are frustrated as citizens, and that the political world is not reacting quick enough, etc. And also we have the scientific basis and the data evidence to deliver to the policy community. So what to do and how to do is really a challenge, I think, both as individual and also as a group, because IPCC has a good principle, which is we are doing relevant science. So we deliver policy relevant knowledge, but we are not policy prescriptive. And which is good. I understand it at the international level, but on the other hand, if you know the good solutions, why you can't not be a little bit prescriptive? Say this is the way to go. But we know that if we do that as a scientific community, then politicians will say, "Oh, that's not your business," etc. So I think that is still struggling to me as big as a challenge. Thank you.
Okay. If there's any, I don't see any other questions coming up. So once more, thank you very much for Professor Chen.
Thank you.
And I would like to ask the next speaker to come on the podium. Next speaker is Mikiko Tanifuji, a project researcher at the Research Center for Open Science and Data Platform at National Institute of Informatics in Japan. Formerly, she was the managing director of the Materials Data Platform Center, National Institute of Material Science, which was the center which developed the Materials Data Platform DICE, or DICE, in 2022. Please, Mikiko.
Good morning. My name is Mikiko Tanifuji. It is my first time to appear at RDA conference. Even I have been involved in RDA for 5-6 years. So it is my great honor. Ali, thank you very much. And now I'd like to enjoy my 20 minutes then. So the first introduction is being involved at GORC working group. And thanks, Andrew, to be patient with me because it took some time to catch up how deep dive I'm supposed to. And this task group 4 is really about this. Oops, sorry. This one. Oops, this one. This red one, isn't it?
It should be this much.
Thank you. Yeah. This one. Inter she doesn't want to go. This one, interoperability. And interoperability, I have spent 6 years for this subject to launch DICE, Material Science, Material Research Data Platform, as well as I'm very sure that NII put even more efforts on this building standards for science domains. So I was very thrilled to be part of this task force. And tomorrow we are going to have a session which really welcome to you all to how deep dive and then come up to the surface of the sea and then what is a common is going to be like. So before that, I would like to update what's going on in Japan in all science domains. And this one, material science DICE, is where I was working up to last year. And NII RDC is what I have started right now to work for. And I think these two are very good examples to share with you today, because material science is really materials oriented requirement. And all sciences, as you all know, never going to end. So where is going to be the meeting point is my concern and also my joy. So I'm very pleased to introduce how picture I see through this all sciences platform in Japan. So big picture, not too deep. So big picture for data platform and data repository, data catalog, and the databases is what have been introduced to science community. And like material science, there are many databases. And as a result of research, so each researchers produce databases to be open and shared within his or her domain. But the data platform looking at much wider place for people to come to work. So what functionality does the platform needs is like not only search fields to discuss or not search integrated search, must be available for how to retrieve the data sets to the local or cloud in your environment. So that does not yet comply with such as repository. Unfortunately, I've seen many repositories through my work. They are search engine, their way to download, but not retrieve as a data packaging to the local so that I can machine learning to that work. So the data platform has to provide that kind of way stress-free, but how to do it is the question, because then there is a concept of commons required behind this. So it's easy to say, but it's not easy to do it. So that's why I like to share with my experiences in NII RDC and also material science case DICE, which target about this scale of users. In summary, nationwide open science infrastructure and NII RDC has 3 core services. One is data management that we all say RDM, and the other one is data publication and integrated search, NII research. And the good part of the NII in Japan is that NII has already provided academic user authentication and network, security network in academia, in locally, and also connected to globally. And that's why I'm saying that it is rather bit ID driven. And on the other hand, DICE is material driven because approach is different. That approach was, there's already existed services that material scientists use day to day. And also cloud service is often very fit well. So they don't have a reason to change one to the other. So what DICE tried to do is to fill the gap, such as materials data repository, which they already have publication repository, but add the data repository into one service so that that's already integrated search. and integrated fetch the data sets from the repository. And also IoT to connect all instruments, over 100 instruments within the institute, to go to the storage for research data management. So this is a different approach, but it is very good practices, which might be interesting to you. So first, I'd like to start the new 7 features of NII RDC. And there's already serviced platform. And then we have 7 reuse, trust, safe, management, interoperable, protection, and training. These 7 elements we found extremely useful to distribute to science community and as well as researchers themselves. For example, I'd like to pick up to be interoperable, the data curation, and also data management. Data management is, Data management, as we all know, so I'm not going to detail because everybody knows the data management plan is a very key function, one of the how to manage the data in the one data centered in organization or in research domain. We utilized the DMP as a part of RDM, so-called Gakunin RDM, for the research institution or could be research projects to use these items. And for example, there's another one, that data curation network is another big challenge, but very new, that we try to connect the people to as a talent pool of the human resources and matchmaking. And so what each people are specialized to what curate for what target for that what purpose, so that the researchers can use the curated, meaning sort of standard followed data sets in science. So after all, the certification batch, so that can be deliverable to research one to the next. So now I can go to the example, use case. So Gakunin RDM, as I said, is a research data management. But in this case, this project, University of Tokyo Quantitative Biosciences, worked together with NII for jointly, that's important, developed a system to manage evidence data. And this is how to publish, process of the publishing article, which might be good news for publishers if they are, that through this process, the Gakunin RDM supports a process of ethic review workflows before to submit articles. So that sort of process is, you might see small, but it's very important, because after the paper is published, and then we want to archive in the research repository, and also we can extract the data mining from the research articles. So all are sort of in the sense of quality guaranteed articles. And another example is there's a so-called Spring 8, which is a large synchrotron radiation facility. We have several facilities in Japan, and Spring 8 is the first use case to use the all infrastructure that NII provide, from the curation part and storage and transfer the data by fast secure network with appropriate user authentication, and also use for the final data set for analysis to share between researchers. In this case, use entire services that NII provide, and will be very good practice to apply for other facility as well. So through these use cases, there's a University of Tokyo provided secured high-speed storage for open academia, and a similar high-speed HPC environment is coming up by government investment. And so as Spring 8 also tried to maximize the value of the facilities to share simultaneously to the desktop of the researchers for calculations. So not only a local necessity for interoperability. Also, researchers wish to connect seamlessly to NOMAD in Germany, and also Blue Cloud international research collaborations, as well as open air, of course, and local day-to-day use applications. So to do interoperable, the top 3 commons for seamless interoperable infrastructure is, I believe, that user authentication, data transferring, and existed applications. And what is not yet fit well to our community is that, like EOS School introduced a very good sophisticated introduction how the interoperability would be like, should be, or aiming to can be collaboration in Europe, which we don't have in Japan, because researchers don't need to think about is what we want to provide. So unconsciously to comply with interoperability is a challenge. So what we have learned, or I have learned from my previous workplace is that this is one example of the workflow or experiment. Physical experiments start from synthesizing samples and also measurement and created a data set and also evaluation and then so on, this cycle. And if this cycle appreciate that DICE service with why not you describe your metadata in the some templates that we provided so that this described metadata can be used materials vocabulary, which also be provided. And if you control in the project, and then all data sets can deliver as a data package on the GitLab that they are already using. So it's like a one package service for them to use to appreciate all the platform. That's what I meant as a data platform is a very important concept. And gradually what I observed is that then researchers started to create themselves add-on service on the GitLab, annotation to data folders. So the name of the data folders goes to metadata to be part of the data package and visualization of the data set so that they can view on the GitLab. So it is a mini lab on Git sort of concept. And what is happening right now is that more dynamic approach that Dr. Hitosugi did is the automate the entire process. And what DICE does to provide the knowledge of how to create vocabulary for his project. And one way is terms, concept, and class by using text and data mining methodology from the open data sets so that he can appreciate to use the template and the data set and customize in his laboratory. And now it's working as a closed loop in his lab. And it's like more automated workflow appeared, not only the laboratory, but also industry in Japan. So my view is laboratory automation is now happening. And what required is improving research productivity and labor-intensive operation laboratory experts require technique and recipes, and so on and so forth. And so it's like laboratory as a service is now the next stage of the data platform. So it's like more like a package in the picture, everything's in one Docker, and then one Docker connected to instruments. And this is, in this case, interoperable requirement. So my summary, what I learned from failure is what I'm saying in not negative way, is that through that DICE development, we created so many sophisticated service come from the requirement of the researchers, but some of them we abandoned because may not be economic to run and may not be interoperable enough, or maybe not scalable enough. And that sort of all reasons that we had to decide to not to take anymore and replace to maybe public cloud service. So that's a create and dispose, that sort of cycle that we learned from the lessons. So therefore, success to the future is user needs oriented, like I introduced use case, and user experience orientated, and fair, to be fair, know-how leading the commons in each research project. So I'm not trying to say that universal commons, but at least each research project would have each own commons. That's the beginning. And then NII try to fetch and generalize and perhaps the acceptable minimum commons to be work and see, and then scale up will be the one day, the bigger commons concept. So my conclusion today is all know-how about FAIR, perhaps like a scheme of Japan Open Research Commons, maybe, can be a good source of the hints on moving towards the more general interoperability. So I'd like to introduce my colleagues from NII, these 36 people, all about this research data cloud. And fortunately, these three of us are here today, and also two experts from internet cyber security resilience, not resident, resilience. And these experts are really good counterpart at NII to make this NII RDC is more reliable security, and also enjoy this fun of the future as an NII institution. Thank you very much.
Much for this very, very interesting experiences what you had. I would already have a question, but maybe we take instead from the audience. It's always better to have an audience question. Please, over there.
Hello, thank you. Very nice.
Hello.
Marek Cywicz, Czech Academy of Sciences. How much you manage to engage really scientists to use your system? Because it looks very helpful, but let's say in your previous position, how much you managed that scientists used it?
In the previous workplace, I have a morning session. I start from 8 o'clock for 1 hour every day, 3 months. I said morning training session for researchers, by researchers for research. Why not? That's the theory. And after the most difficult part, so I had 77 staff at the time, visit and discuss, even including researchers to be part of designing the architecture of the system, because we do not make everything what they say, of course. We pick up and some not pick up, but some not pick up, how can I replace to something else, which they might already use like GitHub function. So that constant communication is really key. And also ask them afterwards. So did they enjoy it? Or what complaints do they have? If that's complaint, what is the source of the complaint is very important.
Yeah, that sounds fantastic, but can you share with us just the idea roughly, what proportion of researchers was really involved in your activity from the institute?
Half. Half of the 77 was research question. Yep.
Thank you very much.
Is one more question?
Thank you. Gerhard Goldbeck, Executive Secretary of the European Materials Modeling Council. I'm extremely impressed by the work you've done, doing, and I wish we had similar things happening in Europe. If I may, maybe people don't like to talk about money, but I would like to talk about funding. What sort of level of funding, now not IT, but going into the material science domain, has your effort had or is having to make this a reality?
Thank you for asking. I wish I could tell, because I'm no longer belonging to NIMS. But I would say that it's huge budget come from the government for this data platform DICE, because in the material science, at least, I'm sure that it's applied to other sciences as well, that data-driven science methodology, machine learning, and AI is a key science styles in materials, as well as working with industry sectors. That's also very important to accelerate development of materials. Therefore, government are very aware of that. This is important area to invest. And in 6 years, that perhaps the whole entire budget scale is like, I can buy the one prefecture in Japan, that sort of scale. Therefore, that our responsibility is huge, so that we constantly make sure not only satisfy the scientists, but also satisfy our funders as well. So that we need a proof, and then we need articles to publish, and we need to appear in audience to share, to get appreciation for our efforts. But thank you for asking.
Thanks once more. I think that was a
Thank you.
very exciting presentation. I would like to ask the next speaker to come on stage. We will have from a little bit more human-oriented perspective and thing which is being developed, to my understanding. The next speaker is Tiamo Mocheva, the incoming inaugural director of the African Open Science Platform, with the strategic portfolio to direct and support this platform. He's going to talk about towards continental open science vision, African Open Science Platform.
So
Please.
this is the one, right?
Yeah, that's it. And then the red one is for the.
Okay. Thank you very much, Ari, for the introductions, and just to thank the organizers for inviting us here and our hosts in Sweden. First time I've been to Sweden. I had tales of ice hotels. I bought all the very warm clothes that I can have, but at least it isn't ice. So this is very good. And I thought I will just maybe pay tribute as well to Hillary. Is he here? Yes, I wasn't consulted with the compendium of pictures that you put together for her session on Monday. But I think one has to say Hillary has done fantastic work in RDA and also engaging with other stakeholders around the world, including working with us in 2019 in Africa, in Botswana, to organize a very successful IDW 2018. There she is in close proximity to power. The man on the left, the Minister of Education, the man on the left of the minister is the president himself. At some point, Hillary was seen whispering to his ear, and ever since then, things have been moving very, very swiftly for us in Botswana. She was also spotted in one of the social events. I saw her yesterday taking pictures and reminded me of this picture that I took of her myself in the evening there. So really fantastic work. It is about connecting people in as much as about technology and other things. So I think it's very, very critical that RDA continues to do the work that it is doing. And we're looking forward to 2027, I believe, when it's coming back to the continent. I would like to see RDA doing more in its strategy to globalize, as you say, and also obviously to sustain and to innovate and lead. And I think globalizing means having a footprint, a representative footprint across the world. So really, I thought 5 minutes of my time, Ari, will just be for Hillary and RDA to acknowledge the good work that you're doing. Yeah. And I think this provided impetus for the work that I'm talking about today, which is going to be carried out for the next 5 years, at least in the first 5 years of implementation of the strategy of the African Open Science Platform, because it is the interactions that we've had since 2018 that has provided that impetus. So indeed, it's more than just technology. It's about policy, it's about infrastructure, it's about skills, and it's about investments in this endeavor. So really, I wanted just to provide a very good overview of what we're trying to do in this space in the continent, notwithstanding the diversity and the multiplicity of challenges. I did mention this picture in the panel discussion, the issue of coordination and scale. I always show this picture because it just shows the immense scale of Africa. I still have friends of mine who are Belgian who think Belgium is bigger than Congo, but Congo is bigger than the whole of Europe. So really put it in perspective, and the challenges that we have, notwithstanding that there are some very, very good documents that talks about how Africa is trying to change the status quo, but also recognize that the challenges are multifaceted, interlinked. I want to mention there the science and technology innovation policy strategy, the digital transformation strategy in Africa, but also the move towards an intercontinental free trade agreement. It's about livelihoods at the end of the day. And we believe open science, science diplomacy, open science diplomacy is part of the answer. I think the efficiency gains that open science brings in terms of making sure that we optimize the little resources we have to spread them across is quite critical. The case for economic improvements is also compelling in terms of innovation and other things. And notwithstanding also that the need for a public discourse, this communication, this engagement between different knowledge systems, indigenous knowledge. I think the Australians are doing good work, and the New Zealanders and the Canadians engage indigenous community. There's a vast treasure trove of knowledge in these communities, including the continent. And indeed, maybe relevant to this panel, the issue of creating global collaborations. We can only create global collaborations if within our own countries, we develop these ecosystems, not only within our own countries, but our regions as well. So I think many countries and many regions in the continent are trying to do exactly this, notwithstanding that we need to optimize the little that we have. There's a very fantastic project led by the South African Center for High Performance Computing that tried to help provide a basis for sharing cloud infrastructures, high performance computing facilities, at least developing capacities in the universities, but eventually making the makings of an African research cloud. We're in very advanced discussions with the NRENs and high performance computing facilities in Southern Africa and also in North Africa to see how we can create such cloud. Of course, if you do those clouds, we know what happens to the collaborative patterns. As sparse as they are in the continent going forward, they will become more dense. And I mentioned this in the panel discussion. There is a basis for how we can collaborate globally. There's a very, very clear declaration that we agreed in Brno regarding research infrastructures. I have to say this needs to be implemented because it provides the basis for the interoperability that we all want. The interoperability that starts with us agreeing at a high level what needs to be done. And of course, if we get this right, the opportunities are ripe in the continent and elsewhere. There I mentioned that the issue of data and accessibility of data can help us discover the next big minds. We know how Africa is really endowed with resources, how we can manage better the biodiversity that we have, that we are custodians of for the world. And indeed, the cutting edge research that is already happening in the continent in terms of the pockets of excellence that we have. The opportunities are there. Space sciences. We have a number of space agencies in Africa doing a lot of fantastic work with partners in terms of launching satellites, doing Earth observation, and of course, the necessary application programs that come out of it. So I'm coming here today to say there are opportunities that together going forward in some areas, we can already have traction, including infusing and perpetuating open science dispensations. Somebody was mentioning funding. Where's the money going to come from? Does Africa have money? And I wanted to share this. I know this is RDA, but still there is potential for finding resources somewhere. If only we can find out where the leakages are. Africa is losing $50 to $60 billion per year through various channels, very well documented channels. This was a study done by UN, UNECA, and AU showing that there are some channels, including commercially related channels, misinvoicing, activities, big companies doing business in the continent, mining companies, you name them. The point being, there's a possibility that going forward, we can find resources, if only we can also look at the inefficiencies, indeed, with other partners as well. The imperatives for us in the continent are as same as elsewhere. I wanted to share those imperatives. I think the issue of open science and its impact has to be measured. So I was very glad to hear that there's some working groups here doing monitoring evaluation indicators in Sweden and Finland. And I believe a lot of work is also being done by UNESCO. The issue of access to knowledge and Africa, how we are shaping that dialogue. The issue of data, very important. I want to mention that is very critical also because you're talking about society, to engage society in the issue of data and their preparedness to engage with it. And the role of our government's top-down approach is let's educate our decision makers amongst the very difficult decisions they have to make regarding investment in these things. Our role as universities, are we configured in this new dispensation to do the right things? And indeed, colleagues, Ari, give me, how much time have I got? 20 minutes now? I've got plenty of time, okay. So there was some baseline work that was done to showcase various activities in the continent that are happening. There is a lot of activity, but you saw the scale. The problem was that of coordination. It's important to coordinate activities to amplify their impact, to create the necessary critical masses so that we can have a commonality of purpose. So there was a need to then say, look, how can we work together going forward as a continent, engaging with others to be able to realize the vision of open science in the continent? A very detailed strategy was developed that we are happy to share with you and that we're in the process of unpacking as and when this thing goes forward. You'll see the pillars there. Mikiko made a very, very fantastic presentation. I can see myself after this discussing vigorously with her how we can engage. But the issue of infrastructure is critical to all this. And indeed, I mentioned what we are trying to do, working with NRENs and high-performance computing facilities to make sure that African researchers stay in the continent and do science in the continent. I made a conscious decision myself in 2012, 2011 to leave London and come back home. But I want to create an environment where we can do the science in Africa, but collaborating with others. I think the issue of policies is very critical because it enables everything. Without policies, you are working in the dark. Colleagues, I also want to mention that the issue of skills is critical, which is why we're looking at the Data Science and AI Institute that not only will look at the data that we accumulate from all the research activities that we do, but also train our scientists and researchers to be more effective. The issue of those projects, the ones that I showed in terms of space sciences and elsewhere, that can make us work together to collaborate, also to enhance our ability to do open science. And I think the two networks at the end there, they are critical. How do we formulate these problems that lend well to society in terms of dialogue with society? I would like to see platforms, both virtual and physical platforms, that allows us to collide in a meaningful manner. Of course, the skills as well. Those who are providing skills, if you are doing training in Finland, why should it not be possible to have that training accessible to others through the collaboration networks that we have? And indeed, for the African Open Science Platform to work, for us, we believe that it must be situated in the different policy and strategy instruments that are already being developed by the regions. So indeed, when we did the cyber infrastructure framework for the Southern African region, there was a very good exercise to look at the policy landscape and engage the decision makers about why this is relevant. And I can say, if this is done throughout the regions, then it bodes very well for the success of the African Science Platform, because it will lend well with what is already existing in terms of the policymakers' thinking. And here's an example of the regional indicative strategic plan. I was invited to a strategy unpacking session. This thing will go till 2027. So it's 4 years to go. The Secretary General is saying, what are the priority projects for the next 4 years? And indeed, if you look very closely in terms of some of the areas that was also mentioned earlier in terms of Professor Chen's work, climate change, weather, disaster risk recovery, and all those things, they are there. And indeed, underneath is data and its interoperability, et cetera, et cetera. And we wanted to position the African Open Science Platform, say, look, we can be part of the solutions. We talk about biodiversity, and Africa, including Botswana and the Southern African region, is host to a whole swathe of globally important biodiversity. Some of these animals do not know boundaries. We need to work together collaboratively. We need to share data about their movements, about the species threats. The Okavango Delta that you can see from space there is the biggest inland delta in the world. It's a UNESCO National Heritage Site. what is it that we can work together in terms of open science and the necessary infrastructure to do things. Genomics, Africa is the most genetically diverse and linguistically diverse continent in the world. Very good science can be done. And indeed, there is a very exciting project funded by the NIH regarding genomic communities and genomic data sets. At the moment, is hosted in private clouds. Going forward, you'll be thinking some of this work could be hosted in the continent. And really, this is a very, very good test case for doing things. In terms of RDA, as I wind down implementation of our strategy, we have a detailed strategy. And I was very excited to hear that RDA is doing a new strategy. There could be alignments in implementation of your strategy and what we're trying to do. And indeed, we should look at these synergies across the board. Very quickly, in terms of what has been done so far, a coordinating hub has been set up. You'll see that there's been a call also for establishing regional nodes in different parts of the continent. Each of the nodes will look at specific pillars of the strategy, and then there will be cross-fertilization of ideas across those nodes. We are working with NRENs in terms of infrastructure. It'd be nice to have other partners who can work with us. I had some very good presentations by industry yesterday. And then, of course, we have a governing council that is representative of our communities. And we've also invited ex-officios to make sure that we are globally relevant. So, colleagues, I'm here wearing a hat of a diplomat. I'm a computer scientist, but I've learned that most of the work is done with diplomacy and with decision makers, because our science is as relevant as is how it blends with them and with society. So really, I want to wind down and say, this is us. We want to increase coordination of activity. We want to amplify impact. We want to make sure that we work together. We want to be globally relevant, and also want to make sure that we create the necessary linkages and we showcase the potential of Africa and the research that is already happening there. I do have many more slides, but I'll stop there, including RDA, our very detailed value proposition, but I think I'll share it for posterity with your audience. Thank you very much.
Thank you very much. Thank you for this very enlightening talk about the developments in Africa. Any questions from the audience?
I normally don't get any because I speak so well, apparently. So.
Oh, yeah, well, you cover everything, but I would actually like to know, you talk about diplomacy, and I find this extremely interesting.
Yeah.
How much from your experience, how much do you have like a really high level policy support from the African countries? It's a very diverse continent, and you probably have a lot of different views. And how do you kind of approach this with the government, which doesn't maybe know anything about?
I have to be careful here because the ASP is not standing on the legs of the African Union.
Yeah.
But we want to create a community of people, bottom up, and organizations that can showcase that this can be done. But I have to say, we worked very well with the Southern African Development Community during the pilot of this project, and other communities as well, where we engaged the secretariat in some of these regional bodies. And we worked on a cyber infrastructure framework that was developed in tandem with SADC to showcase and check how we can work with government officials. I think the challenge is making sure we've got the necessary interfaces. And I think you can only make those interfaces by demonstrating value. So I think we are doing a bottom-up approach. So I think eventually with this traction, we may be able to get more support, yeah. But I think we also looking to engage governments in terms of policy formulation. There is gaps there, and I think there's some reception in terms of them wanting to get assistance with policies, as and when, because UNESCO requires, for example, reporting on progress of some of these things. So to answer your question, we are starting out. We want to demonstrate value, and we also want to make sure that governments can see the potential of this, and also working with officials to try to train them. Yeah.
Okay, great. Thank you. There's a question?
Yeah, we have a question from online. So to what extent are different language traditions a hindrance to the development of the African Open Science Platform?
No, definitely. I mean, you look at Africa, you go to different regions, you know, you've got Francophone countries, you've got Portuguese-speaking countries. But I think diversity of language is a good thing, isn't it? It allows us to then see how we can work together. It is a hindrance, obviously, but there are various communities in Africa doing fantastic work in those different regions, which is why we are looking to institute these African Open Science Platform nodes in those regions so that we can get activity going on there. I think the challenge is a global challenge. How do we communicate across language barriers? And indeed, it's the same challenge elsewhere.
Great. Thank you. I don't see any other questions from the audience. So
Yeah.
once again, thank you very much. Thank you very much. It was very enlightening. And I would like to ask our last speaker to come on stage. Dick Pleiter is a professor of high performance computing at the Division of Computational Science and Technology at the KTH Royal Institute of Technology in Stockholm. He joined Jülich Supercomputing Center in April 2011 and was appointed professor at the University of Regensburg in parallel. Please come and say.
Thank you. Thank you so much for this invitation. It's really an honor to be here at the RDA Forum. I would like to actually add another facet to what we had been seen in the previous presentations and talk specifically coming more here from an, say, infrastructure perspective of what I say is still the challenge ahead when integrating HPC, and actually the interoperability is here, of course, and a very important theme in that. I will actually start to look a bit in the past and also to give you a bit of a flavor of how fast HPC is moving there, because HPC in one sense is moving extremely fast when it comes to technologies, when it comes to organizations and opening up. There we have still very big challenges. I mean, HPC is of course coming, say, from this more tradition of, say, building up silos, because we are working with very critical technology which is to be protected. And I see that there are still a lot of struggles of how do we open up and integrate that such that they can also be used by international research collaborations. And so I will then touch on a few current integration shortcomings and also discuss some of the solution strategies which we have been exploring in the context of one specific project. Now, let me start with looking a bit back, I'm originally, say, from physics, even so I moved now to computer science, and that was an area of simulating, say, the theory of strong interactions, also known as quantum chromodynamics. And you can formulate it on a lattice, and that's why it's called then lattice quantum chromodynamics, or in short, lattice QCD. And it's still really, say, an exascale requirement, so there's a clear need for high performance computing. But as I will also show you in the next slide, it's also a lot about, say, data. And that's why there had been an initiative which was called the International Lattice Data Grid. And that was already started in 2002. So more than a decade before, say, the FAIR principles were announced. But as it turned out later, I mean, we were pretty close to, say, what was later called in the FAIR principles, because it was at the beginning already, say, putting, say, standards for data in place, standards for metadata, data formats, but also for building up an infrastructure. So therefore also, for instance, putting out standards for web services interfaces. And then to build up, because this is an international community, and we wanted to share data really at the global level, to put a grid of grids infrastructure for data sharing. And that was mainly an effort with, say, various sites in the European Union, Japan, UK, and the US, and mainly stitching together, say, different parts which were there, but then still also having, say, a single global virtual organization, so which we, for instance, also were managing, for instance, the community and the access to these storage resources. Now, without going to the detail, but just at the very sketchy, what is a typical Lattice QCD workflow? Well, most of the cycles you spend in producing data, which is called gauge field configurations. And for this, you would really like to use very large supercomputers, because it's essentially a Monte Carlo algorithm. So you have to do many iterations to create a lot of statistics. So I just put as an example here, for instance, the Lumi supercomputer. And then you put this data on storage, but this itself doesn't give you, say, much science. Because then you have to go in a second step, and that's where you can also use smaller systems. I just put here more for an example, say one system which is in Bulgaria, the other one is in Luxembourg, where you then can do computations for actually then computing physics observables, and this is what you then can actually then use for your publications. So you have a very clear case for HPC, and you have a very clear case for being able to use this data and to actually also share this data, because once you have these gauge field configurations, there are multiple ways of how to exploit this data in order to produce science. Now, even so, this is already, say, more than 10 years, or actually more than 20 years ago, sorry. Still, if I look around, if I look what is, say, still state-of-the-art integration of HPC and data infrastructures, I still find at many centers that I have, say, my FastPearl HPC file system, and in order to connect that to some data infrastructures, and just at an, I didn't have made any attempt to be comprehensive. This is just examples like the word, the LHC grid or EUDAT, or also public clouds. I just put here the logo of Amazon. Centers put a bunch of servers in place where then a user can log in, has access to the fast HPC storage, has the clients to communicate with the data infrastructures, and then you move data back and forth. Now, we have seen, say, quite a number of much more complex workflows which are coming up or which are existing and implemented in the context of material sciences or bioinformatics, and I will also make the case now for brain research, where this is clearly not sufficient. Now, what are, say, the shortcomings? And I just want to focus on 4 of them. It is in particular, say, the identity management, which I think is a key where, say, a lot of things would become much simpler. If you look at today for the HPC services, I mean, we are typically here dealing with local accounts. And that is, of course, not a good prerequisite if you then want to actually be able to have an authentication. And it's about, say, a community which is worldwide organized. There's also this question of access control management, because we have, and I know it also from the community which I was previously introducing, that they do not want their data to be, say, generally public, or maybe not immediately to be generally public. And therefore, you need to have some kind of access control. But still, if you look at today, where do we stand with, again, when it comes to HPC, things are much more, say, storage architecture or system and site specific. The next item I want to touch on is deployment of externally accessible storage and processing services. So, as pointed out earlier, HPC centers still are a bit more having their coping with their DNA of building, say, silos, well protected, and it's not so easy to get in and out. And we are still, say, in, say, a process of transiting to, say, a situation where we can have also storage resources. It's not necessarily the FastPearl file system, but to also have storage resources and corresponding data services and processing services, which could be just, say, a virtual machines or some Kubernetes cluster available, which are then externally accessible. And then, of course, if you have this kind of setup, which you quite quickly will drive you to have, for instance, when it comes to storage, having multiple storage entities, have then also the proper support for data transport and data management services. Now, I think there's one development which will help us, and that is where I see, say, also the future for HPC data centers, and that is largely, say, driven by the needs of existing, or the changing needs of existing user communities, as well also the needs of emerging new science and engineering domains. And the Linux QCD community is a very small community. I mean, here I'm talking about much larger communities, which are really, say, will help to push these organizations when it comes to support of collaborative research, when it comes also to provide wider access to HPC enabled by high-level services, so that you have predefined workflows which you can trigger through a web-based interface, science gateways, or collaboratories, as they are called in another context. But it's also about enabling workflows which extend beyond the HPC centers. So keyword would be here, the computing continuum, and then to be able to also support workflows where we have then geographically dislocated services, but also extending to edge and IoT. But then also to support the ability, the deployment of domain-specific platform services. So what does it mean for the HPC centers? Well, it means that you have to move away from, say, what is still a typical model today, that you're operator of one or a few HPC systems, to actually be a federated infrastructure services provider, where then as a single site, you are providing services based on different types of compute and storage resources. And HPC is one of them, but other ones will be obviously be based on more on cloud technologies, right? I mean, it's not necessary that we become a cloud providers, but at least we should adopt things which are coming then from the cloud. Now, one of the one of the science drivers which we have seen to be quite helpful in the last 10 years. And that was due to a very large European flagship project, the Human Brain Project, which led to what is now called eBrains, which is an European research infrastructure for brain research. And it had been accepted for the ESRI list in 2021, so it's still a newcomer. But I think it's now really making its way, and it's really it's now has become a legal entity, and it now has a mission of really providing services for a diverse but also geographically dispersed research community. And that makes, of course, things very challenging. But what makes it very interesting from, say, the HPC infrastructure's perspective is also, say, the diversity of needs and the requirements which they have. So they do have, on the one hand, very clear HPC requirements because they want to do simulations at quite different scales, so that they need to do, say, large scale and coupled simulations when it comes to pushing, say, also the size of the brain networks and also, say, the precision of these models. But on the other hand, you also have, say, quite a large number of research teams which are working on images, so brain images. And if you go there to a micrometer resolutions, I mean, we're talking here quite quickly about petabytes of data, which needs to be analyzed with quite advanced numerical methods. And then again, it becomes an HPC challenge. But then all this in combination with the need of having interactive access to compute resources, but also to be able to process extreme scale data sets or to visualize them, but also to make HPC and the different service much more accessible through science gateways, or how they call it, their solution, they call it the collaboratory. Now, when the HPP started in 2013, I mean, there have been 5 of the very large European supercomputing centers being involved. And in the course of this project, we did realize of how diverse this community is, and that there is, say, a need of actually, instead of going for one big computer where you can do this one big brain simulation, to actually, it's much better to provide, say, a federated infrastructure where you can serve the needs of this community. And that immediately put us in this challenge of how can we open up, say, the HPC center. And the concept where we then end up with, say, trying to provide, say, an abstraction where on the one hand, we have our HPC environment, which I put here in this red box. But we have here something which we then called scalable computing, but this is essentially, say, the HPC. But using basically the same real estate in terms of hardware, we can also use that for interactive access. So that's why we have interactive computing. And that is done still in a protected environment, and we'll still also talk to something which is, say, very fast and say fast parallel file system to work with a POSIX interface. But we called it then an active data repository. But then we also have to have these other outside looking worlds, which are called here a cloud environment, where we have then, for instance, virtual machines. And if you would have started a few years later, we would have immediately put into the picture here also container orchestration services, but they are connected to what we abstracted here as an archival data repository. So that are, say, data repositories which are being federated. So what it brings us in this Phoenix architecture, is how we called it, is that we have now the externally accessible processing services with these virtual machines, and we have external accessible storage services. And here we made one decision, which is still, of course, something which we can discuss, but in order to make for us things simpler in terms of integration of AI and unifying, we here made a decision of saying, okay, we mandate here one particular interface, but this is something which I expect also to change in the future. Now, whenever you want to basically process data here inside, then of course you have to move data between, say, this cloud environment and this inner environment. And that's where you have to be able to, say, move then data. And then we are, say, with the data services, and there's 2 types of services which you have foreseen. So you can now think about this of being, say, two different sites. So within one site, we still have, say, the challenge of how do we automatize, which was previously in this picture, say this, the interactive service where the user could type. How can we actually put services in place? And that's where what we call then data mover services, which is, say, then typically then being able to move or copy data from a storage here, which is talking Swift, to a storage which is typically talking POSIX. And then, of course, we also want to communicate between the two different sites, and that's something which we call then data transfer service. And here we decided to use something which is, say, quite well established and have been, say, well tested in the wild at large. So we took, say, technology coming from the LSC grid called FTS, and developed it a bit further so that it supports actually Swift, and that enables us to actually do data transfer, for instance, from Swift to Swift. But those who know FTS know that there are also other protocols are being supported. So it actually also provides us with some gateway to move actually outside of this Phoenix infrastructure. And we actually do have also ongoing projects where, say, for instance, there's some EOS science cluster involving the high energy physicist, but for instance, also because there was in one of the previous slides, for instance, also the radio astronomers in SKA, which are involved there, and they are, say, setting up in Europe, say, a data lake, and they're very interested in being able to show, okay, can we move data from our data lake in the archival data repositories, used in the data mover service in actually being able then to leverage, say, HPC compute resources. And I think we're now pretty close to having that in place. So this combination of these services is now really enabling then the integration of HPC and data services. Now, this is at the end, if you look at it more detailed, is not as trivial because, I mean, we have, say, different types of authentications. So if you come, say, from the outside, I mean, you need to, say, request tokens in a federated AAI, and then we provide this to a data mover service, which then has to be able then to authenticate those with, say, that is the active data this is the archive data repository with where you have an object store where you can authenticate with the tokens, but then you have here on the right hand side you have then these active data repositories, so the HPC file systems. So coming then to the identity management, and that's where I think we still have some more work to be done, and say where I would end up hope for that we move away from, say, what is the current situation, that at the HPC data centers, you typically, the HPC data center, they manage their own user accounts. So in cloud terminology, they act as their IDP, but only for themselves. And where we should get to in the future is that actually the HPC data center stop doing that, and delegate this to IDPs and support federation of IDPs. So the data centers would then become real service providers. And this is shown also here in a picture that is now termed My Access ID. And you can see here, I mean, this is part, say, of the Phoenix, but there's also, say, other, say, infrastructure services domain, like the one which is also including Lumi. But they can then connect to a common AI services layer, so which we then can connect to different IDPs. So in this way, there is an opportunity now to balance, say, the need for tightly controlled access to the HPC environment, as well as also the need for supporting a broad but authenticated access to data and other services for then supporting international communities. Now, touching also very quickly on, say, the data access management and actually making it coherent, that is still and will continue to be a challenge. Coming from the HPC, we are typically talking about fast parallel file systems with a POSIX API. That means we have access controls to POSIX file modes, different flavors of ACLs. And then we have, when we go then to the data infrastructures, we have various APIs. So there is even the larger diversities. And now the question is, how do we put these things together? Now, I see at least one path, and that's what we try to push for in Phoenix, is to say, okay, we have this separation, this conceptual separation between active data repositories and archival data repositories, where, say, the active data repositories with the POSIX API, say they contain just private data entities. So this access management basically is not an issue there because it's private copies. But then when we go to the archive data repositories, that's where we have to make sure that you can say have a coherent access management. Now, this could be either realized by demanding that you have, say, a coherent API. That's what we currently did in Phoenix. But you could also say assume that you have, for instance, there still a distributed domain-specific data management layer, and you could, for instance, use technology like Ruscio, which is currently, say, pushed very much by CERN. And looking into the future, we could also imagine that we have here, say, more of a standard, and that is really more a question of how to standardize it, because the technology is basically there in how we, say, conceptualize it, and how we also put, say, attributes services in place, that we use the token-based interfaces then also as a basis for then implementing then token-based authorization. So with that, I come to my last slide. Unfortunately, we still have quite a gap between services and resources which are deployed in an HPC environment and then to connect out to the data infrastructures. But I think that the transition which, say, different HPC centers are undergoing, and if you look, for instance, since we now still have the EuroHPC summit ongoing also here in Gothenburg, if you look at the different EuroHPC systems which have been deployed in the last couple of years, they are all deploying also, say, more cloud technology-based services, so you can really see that this transition is materializing. But there is still a lot of work which needs to be done in order to address the different shortcomings which I have been mentioning. Say, how do we get to a much more streamlined identity management, which is much more suitable also to integrate in international organizations, international research organizations? How do we improve on the data access management? How do we also streamline, say, the deployment of externally accessible storage and processing services? Even so, these services are now, these opportunities are now getting into place. We still have quite a lot of diversity in the way of how they are operated, how they are become accessible to the researchers. And then we also have to work on how to make data transport and data management services available. With that, thank you very much.
Thank you very much. We have now some time before the coffee break. So if there are any immediate questions, please, from online.
Yes, we do. In the medical domain, where sensitive data cannot be moved, the idea of tools moving to where the data resides is gaining traction. Could you comment on the efficiency of this approach versus data movement?
Yeah, that's a very good question, and that's say touching yet another challenge which I left out because I would otherwise have run out of time. I mean, there's certainly also, say, an area where we need to improve as HPC centers when it comes to data processing is how to process ISO-sensitive data. Now, I would argue, okay, I mean, while I put some emphasis in being able, I mean, to move data also between different sites, I mean, here we're talking clearly also to, say, on a topic where we have to have very clear control on where the data is actually being moved. But here I see also the opportunity that by in this strategy, you're actually supporting then federated infrastructures and therefore increase the opportunity to actually keep the data locally, also then within one governmental domain, and therefore avoid also the issues which you would have in order to move the data across the borders.
Please, over there.
Hi, Bob Hanisch from NIST in the United States. I've been advocating in the US for building something equivalent to what we see in EOSC here in Europe, what we just heard about in Africa, sort of an open research commons. And in the US, HPC facilities, major data facilities are all managed by different branches of the US government. You are building systems that federate across HPC platforms. How have you dealt with the issues of what I would call provincialism or ownership? Do you find that the managers, the policy holders of these different centers are willing to cooperate, or do you have to offer them some incentives to open up their systems to this federated approach?
Yeah. Well, definitely you have to provide incentives. I mean, there are multiple things which play into that. I mean, it starts from, say, the ownerships. I mean, part of the systems are nationally funded, but here there's an emerging opportunity that now, say, quite a large number of systems are say quite a significant number of systems in the foreseeable future, and actually the largest systems will actually be partially owned by a European organization. That's the joint undertaking Euro-HPC, and they are actually now pushing for having this kind of federation. So this is really, say, a window of opportunity. Now, there's also, say, the psychological element in the sense of that centers, HPC centers directors, I mean, they get more the credit of doing something special. and now to actually, say, collaborate in this sense is also not always easy. But I think what was done in Phoenix shows that there are opportunities. It is difficult, but I would say it's difficult at quite a number of levels. So it requires a lot of interaction. It also requires a lot of getting trust and to be able to align, say, the different strategies of the different centers. What I think at this point is maybe even, say, the biggest barrier, which is say less of a problem in the US, that say the difference between the different states is much less than the difference which you have here in the different countries within Europe. So when it comes also to say local laws, which can play when it comes also to security requirements, that's where, say, a lot of issues are still hidden, and where also when it comes to, for instance, the Phoenix infrastructure, I mean, at some point we just said, okay, I mean, the best which we can do is to offer the user a one-stop shop, and then try to all the diversity behind it, whether you can just click to agree to the user agreement or whether you still have a paper form. You do have it. I don't name the country, but at least in one country, it's for sure you need it to hide it behind that. So that are the kind of things where you still need to have a pragmatic approach. But I would hope at the end, and that is also what I see also driving things a lot, that is really the science drivers, which make, say, this also, say, the different centers realize that they have to undergo this transformation, that they need to say work towards this federation.
Thank you. I don't see any other questions. Oh, there is one more. Final question for this session.
I'm here.
The microphone doesn't seem to be on. Okay.
Okay. I'm Chelsea Davian from the Observatory of Paris. In astronomy, we have a few projects with a large amount of data. And to face the problem of HPC and user access, we're now developing what they call science platform. So it's part of cloud, talking to the part of HPC using the same software pieces you were describing. Do you follow these evolutions? And it seems that there is quite few of them, and they don't all use the same technology yet. And we have a very huge project called SKA trying to face this kind of problem. Is there some answer of your questions or in this evolution of projects?
Yeah. We try to follow it, and I mean, USA community, which is also, say, at the European level, for instance, represented in EOS through the Escape Science cluster, and we are, say, engaging with this science cluster and running here also, say, proof of concepts in order to be able to interface with that. I mean, I wouldn't say claim that we are already there. We are still, say, very much at the point where if you want to enable, say, this kind of access, also as it was described here, that we are on site-specific solutions, and that's where we have to get away. I mean, if I look in my older community, say the high energy physics community, I mean, I was also embarrassed by seeing, say, at various conferences, say the description of essentially what you call edge services, but in the sense of the edge of the HPC center services, which were all specific, right? Then say one team did it for side A, the other did it for side B, and essentially we're reinventing the wheel because they were just accommodating to say the different ways of how it was locally organized. And that's what is to say also behind this abstraction here. Even so, we started from the brain research community. We try to define these abstractions in a way that is also suitable for a setting out the community. And in particular, also say the physics experiments, various communities around physics experiments was ones which I definitely had very much in mind, also because of my background.
Great. Thank you very much. Thank you very much for our speakers, all of them. And thanks for the audience for coming on this morning session after the dinner, which is always more difficult. And now it's time for coffee. So thank you.